Hey ProbStats kids, this is Dr. Callahan for Probability and Statistics for Semester 1, Week 5, Friday. I hope you guys are having a good time at home with virtual learning, consecutive day number 6. I am hoping to see you guys on Monday. So go ahead and pause the video and answer the 3 warm-up questions in your warm-up log. All right, so if you have looked at your grade and it's been updated, if you're not satisfied with it, you guys are welcome to go to the Google link, do your missing assignments, and then go ahead and send me an email with a picture of it, and I'll be more than happy to update your grade. So keep that in mind. All right, so today we're going to go ahead and talk about section 11.4. We are actually going to be finishing that today. We're also going to be looking at, do you know your card questionnaires? And then you're like, what kind of cards? Like a deck of cards. We live in Nevada, gambling, casinos, cards. So do you know how many cards are in a deck? How many black cards? How many red cards? How many spades? Because before we start doing probabilities about cards, you have to know all the hands of the cards. If you need to go ahead and do a little refresher, I have a video. It's about 8 minutes on probability of a regular pack of 52 cards. For your homework, your job is to memorize the questionnaires on the deck of cards. Number 2 to 26 evens. And with that said, let's go ahead and get started. So the theoretical probability of an event is the number of ways that the event can occur divided by the total number of outcomes. It is finding the probability of events that comes from a sample space of known equally likely outcomes. So here are the steps or formulas to compute theoretical probability. If an event E has N of E equally likely outcomes and a sample space S has N of S equally likely outcomes, the theoretical probability of an event E, which is denoted by P of E, is going to equal to the number of outcomes in event, N of E, divided by the total number of possible outcomes, N of S. So let's take a look at example 5, okay? A die is rolled once. Find the probability of the rolling. Well, before you proceed any further with this, take a look at the face of a die. What are the probabilities? When you roll it, you can have a 1, you can have a 2, a 3, 4, 5, or 6. So what is the total number of possible outcomes when it comes to a die? Well, that would be 6 because there are 6 different possible outcomes or 6 different faces of a die, singular. So let's take a look at the first question. What is the probability of rolling a 3? The total is out of 6. Well, there's only one face that has a 3. So your probability is 1 over 6. An even number. An even number would entail a 2, 4, 6. That's 3 out of 6. And if I go ahead and reduce that, it will be 1/2. So your chance is about 50%. A number less than 5. A number less than 5 is going to be like that. So not including 5. That will mean you can have either a 1, a 2, a 3, or a 4. So there are 4 possibilities out of 6, which is a 2/3. And D, a number less than 10. Well, all the numbers on the face of a die is going to be less than 10. So that will be a 6 over 6, which is a 1, or what's the probability in percentages? 100% that you have when you roll a die, it will be at least 1, 2, 3, 4, 5, 6. A number greater than 6, well, since the face of a die stops at 6, that's a 0 out of 6, or just 0. or 0%. There's absolutely no chance they're going to roll a die that's going to end up with a 7. All right, now let's go ahead and talk about faces of a card, or different cards. So pause the video, and in your notebook, take a look at all the possibilities here, and then answer questions 1 to 13. All right, are you guys ready to go over this? Let's take a look at this then. How many are face cards? Well, actually, how many are total in a deck of cards? Well, given the fact you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 columns, and 1, 2, 3, 4, 4 rows. 13 times 4 is going to give you 52 cards. How many black cards in the deck? Well, since there's only half that are black, 52 divided by 2 is going to be 26. And similarly, the other half is red, so there are 26. Next question is, how many are face cards? Well, face cards are going to be cards that have faces on them. So Jack, Queen, and King. So that would be 4 times 3, which is going to give you a 12. How many are Queen cards? Well, Queen, there are only 1, 2, 3, 4. So your answer will be 4. King, same thing. 4 King. Aces, 4 aces. Jokers, 4. I'm sorry, 2. Jacks, 4. How many are hearts? Well, your hearts are going to be all of these cards right here in green. And as we established before that there are 13 columns, how many is spades? Spades are going to be, I actually don't know which one is a spade. I know that this is a diamond. This is a heart. I'm just gonna make a guess, and I'm gonna say that spade is this one with an upside down heart. I'm actually not sure, but it would be 13. I know that for certain. Diamonds 13, clubs are 13. Don't worry, after this, I would definitely be Googling that. Okay, 3 scenarios with theoretical probability. First one is gonna involve a die. Second one is gonna involve a deck of cards, which we just went over. And the next one is a coin, so a coin toss. Those are the 3 different setups. All right, let's go ahead and take a look at this. The sum of the theoretical probability of all possible outcomes in a sample space is 1. 1 meaning that it is going to be 100%. And my pen is having a little bit of difficulty. Here we go, 100%. All right, so with that said, let's go ahead and go over a few examples. You are dealt 1 card from a standard 52 deck. Find the probability of being dealt. So then remember, your total outcome is going to be out of 52. Whatever number you have on top is going to be a king, a heart, a king of hearts. All right, so let's go ahead and take a look at this. So how many kings are there in the deck of cards? There are 4. 1 king for spade, 1 king for hearts, 1 king for club, 1 king for diamond, so 4 out of 52. Well, I can go ahead and reduce this if I divide the top and the bottom by 4, which will then give me 1 over 13. And that is my answer. Now, if I want you to write this in terms of a probability, you would do 1 divided by 13 on your calculator, which will give you a 0.077. That's in decimal form, so if you want to convert this into percent form, you'll do 2 decimal spaces to the right, which will give you 7.7%. What are the probability of getting a heart? Well, with a heart, there are 13 of them out of 52. And I can actually reduce this if I divide 13 in the numerator and denominator, which would give me 1 over 4. And if you put this in percent, you do 1 divided by 4 in your calculator, which is 0.25. But then you have to convert this from a decimal to a percent, which will then result in a 25% chance of you getting a heart in a deck of cards. King of hearts. Well, I know there are 4 kings and there are 13 hearts, but in a set of 13 hearts, there's only 1 king. So it's 1 out of 52, or 1.92%. Make sure you guys are practicing this by using a calculator so you know how to divide fractions and convert them to percentages and then also to decimals. All right, guys, I'm going to go ahead and stop here. Normally, if we're in class, we'll be doing a quizzes, but I feel like this is enough for one day. So I will see you guys next time. I hope you have a great weekend, and I hope that we will resume school on Monday. So I will see you then. Take care.